Hi, this instructional video is about rewriting quadratic function into vertex form. Now, here's an example, number 1. Y is equal to x squared plus 26x plus 68. You see, this is a standard form. You may recall it's written as y is equal to ax squared plus bx plus the c. Now, we're going to change that into what you recall as being written as y is equal to a times the quantity of x minus h squared plus the k, where the inverse of the h, in case negative h and k, they represent the vertex. And we have to be able to go from standard to vertex form, and here's how it's done. Now, it may seem very elementary, but it works. Check this out. You go y plus, leave it blank, equals x squared plus 26x plus, leave it blank, and bump that 68 over. Because whatever you do to one side of the equation, as long as you do it to the other, it makes it okay. So what we're going to do after that, we're going to build a fence around this trinomial, right there. And now we're going to complete the square within this trinomial, make it a perfect square. And to do that, you have to first identify the b, and the b is the 26. And whatever the b is, you take half of that, or divide it by 2, and whatever you get, you square it. So 26 divided by 2 is going to be 13. And when you square that, I believe it's 169. So now 169 is the perfect square, and that's what goes in here, 169. But whatever you do on the right side of the equation, you do it to the left, 169 here as well. Now that this is a perfect trinomial, or perfect square trinomial, we're going to factor it. And we're going to carry the 68 along. And the question is, what times what is x squared? And that is x and x. What times what is 169? It's 13 and 13. And what must the 13 signs be? So when you add them together, it becomes positive 26. Well, they both have to be plus and plus. And on the left side, we haven't done anything, so it's y plus 169. Now, since they're identical binomials, we could simplify into a single term, x plus 13 quantity squared plus the 68. And that equals what's on the left side, y plus 169. It's starting to look like a vertex form now, doesn't it? Now, we start to solve for y by moving the 169, and to do that, we minus 169 to both sides of the equation, and we line them up. So on the left, 169, 169, additive inverse cancels out. Y is equal to x plus 13 squared. And 169, take away 68, positive, it's going to be, well, negative, what is it, 101? This is your vertex form. And what's the vertex? Since vertex is identified as the h and the k, the inverse of 13 is negative 13 for h value and negative 101. It's going to be way off the scale on the coordinate plane, but there it is. Now that you see that, you try this one. Good. Now you will see, if you're kind of thinking, hey, maybe I could factor this, huh? No, you know that only 1 times 1 is going to be negative 1. But you know they cannot add or subtract to become 7. So this is not factorable. Okay? So we're going to make this into a vertex form. Here we go. So same routine. Y plus, leave it blank, equals x squared plus 7x plus, leave it blank, and bump out the negative 1 over here. And you build a fence around this trinomial, which will be a perfect trinomial, square trinomial. Now what goes in here? Well, you take half of the b. Half of the b, half of 7 squared. Oh, this ain't gonna be pretty. Since they don't simplify, they square to become 49 over 4. Yep, and that's what goes in here. And whatever you do on the right side of the equation, you do it on the left. Now you could factor this. Yeah. So the question is, what times what gives you x squared? And that's x and x. What times what gives you 49 over 4? That's 7 over 2 and 7 over 2. Now what must their signs be so they add to be 7? Believe it or not, I'll show you in a second. They're both plus, because check this out. 7 over 2 plus another 7 over 2. Isn't that 14 over 2? And doesn't that become a 7? Whoa! Oh! Yeah. And what's on the left side of that is y plus 49 over 4. Now we're going to simplify this two binomials as 1, x plus 7 over 2 squared minus 1 on the right, and on the left is still y plus 49 over 4. We're going to solve for y by moving the 49 over 4 and line them up with the like terms. So you end up with a vertex form, as ugly as it is. Y is equal to the quantity x plus 7 over 2 squared. And since they're both negative, it's going to still be negative. And 1 is like saying negative 4 over 4. So it's going to be negative 4 and negative 49. It's going to be negative 53 over 4. Whoo-wee! It's not pretty, but it's a good answer. And the vertex, the inverse of the inside component, which is negative 7 over 2. And the k value is going to be as given, negative 53 over 4. There you have it. Look for part 2 for some more. That is coefficient other than a 1. Good luck.